snow's coming down sideways outside my kitchen window. The power's been out for 6 hours, and I'm standing over my kitchen sink with a headlamp on, listening to my well pump click and click and click and never catch. No water pressure. None. Outside it's 12 degrees and dropping, and every pipe running under this house is about 20 minutes from turning into a solid rod of ice. My wife's asking if we've got enough bottled water in the pantry to get us through the night, and I'm doing math in my head about how many gallons a family of 4 actually burns through in a day, and the number's a lot bigger than most folks think. That was a few winters back, and it's the night that got me building the setup you're looking at right now. A rainwater catchment system behind my house that holds a few thousand gallons of clean water, gravity-fed and gutter-fed off my own roof, plumbed straight into my house pipes. I'm not talking about a rain barrel under a downspout for watering tomatoes. I'm talking about a real system, filtered, pressurized, and good enough that we drink out of it every single day. And I built almost all of it myself, out of parts you can get at a hardware store or off the internet, for a fraction of what most folks think something like this costs. By the end of this video, you're going to know exactly what it takes to set up a rainwater system of your own, even if all you want is a modest version of it. I'm going to walk you through how much water actually comes off a roof when it rains, the real number, not the exaggerated one you hear floating around online. I'll show you the pipe sizes that actually work versus the ones that clog up on you in the first storm. I'll tell you what a metal roof does for your water that a shingled roof doesn't, and why that matters if you're planning on drinking any of it. I'll break down the filter setup piece by piece with rough prices, so you know exactly what you're buying and why. And I'll tell you flat out which parts of this project you can knock out yourself in a weekend, and which parts, and there's at least one, you want a professional handling, because getting it wrong isn't just annoying, it's dangerous. My name is Frank. I grew up in a wood frame house back in these same woods, same general patch of dirt I'm standing on right now, just a different house on the property. My dad, my grandfather, a couple of uncles who did carpentry and ran small farms, that's who raised me, more or less. When something broke out here, you didn't call anybody because there wasn't anybody to call, or if there was, they weren't coming for 2 or 3 days. So you learned. I learned by handing tools to my dad before I was tall enough to see over the truck bed, and by the time I was a teenager, I was the one under the truck. Water's always been part of that education. My grandfather had an old cistern out behind his barn that he built with his own 2 hands sometime in the 50s, and he used to tell me that a man who doesn't know where his water comes from doesn't really own his house. He's just renting it from whoever runs the pipes. I didn't understand what he meant until that night the power went out, and I was standing over a dead faucet with a headlamp on. So here's what I'm going to teach you today: how to set up your own rainwater catchment system. Whether that's a small backup tank for emergencies, or a full-blown system like mine that handles your whole house. And here's the injustice of it, because there is one. Most folks think a setup like this costs a small fortune and needs some kind of special engineering license to pull off legally. Neither one of those things is true. The parts of this project that cost real money are the parts almost nobody actually needs: the fancy pre-built kits, the oversized tanks, the contractor markup on labor that you can do yourself with a shovel and a Saturday. Meanwhile, the parts that actually keep your water clean and safe are cheap, and almost nobody talks about them, because there's no profit in telling you a $5 filter sock does most of the heavy lifting. Stick with me to the end, because I'm going to tell you exactly where the real money goes on a project like this, and where you can save yourself a couple $1,000s without cutting a single corner on safety. Here's what most people get wrong when they think about collecting rainwater. They think the hard part is the tank. It's not. Tanks are simple. They're just big containers. The part that trips people up, and the part that turns a good idea into a mosquito-breeding, algae-growing, contaminated mess, is what happens before the water ever reaches the tank and after it leaves it. If you don't get the roof, the gutters, and the filtration right, it doesn't matter how big or expensive your tank is. You'll just have a large tank full of water you can't trust. I've seen fellas around here spend real money on a beautiful tank and then run cheap, undersized pipe into it with 6 bends and no slope, and wonder why it overflows in the first hard storm and floods their yard. Get the water moving right before you worry about where it's going to sit. So let's start where the water starts, the roof. If you're setting up a system with drinking water as the goal, you want a metal roof if you can get one. Asphalt shingles can leach small amounts of chemicals into water running over them, especially in the first few years after they're installed, and that's not something you want ending up in your drinking glass. My house and my workshop both have metal roofs, which was more luck than planning. My dad put a metal roof on this place back in the 80s because it held up better against falling branches out here in the woods, and it just so happened that decision paid off twice. Now, how much water are we actually talking about? For every inch of rain that falls on 1,000 square feet of roof, you can expect to collect somewhere around 600 gallons of water. That number surprises people every time I say it, but it holds up. I've measured it myself over a few storms with a simple flow meter. My house and workshop combined give me a little under 3,000 square feet of catchment, so a decent 1.5-inch rain event can fill a hefty chunk of my tank in one evening. Out here we don't get rain every week, but when it comes hard. And that's exactly the kind of roof that makes a system like this worthwhile. Before you pour a single dollar into a tank, you've got to prepare the ground it's going to sit on. And this is where a lot of folks cut corners they shouldn't. A tank full of water is heavy. I mean seriously heavy. Thousands of pounds once it's full. And if it's sitting on ground that isn't level and compacted, it will settle unevenly and stress the walls of the tank until it fails. I built mine partly below grade, which meant digging out the site and building a retaining wall to hold the earth back, which is its own project I won't get into fully here. But the short version is this: get your site level, get it compacted, and if you're going below grade at all, get an engineer or your tank manufacturer to sign off on the wall design. That's one of those places I mentioned earlier where you bring in somebody with real expertise. I'm not an engineer, and dirt pressure against a wall holding back thousands of gallons of water is not something you want to eyeball. Once the site's prepped, you level it out with a few inches of sand, then rent a vibratory plate compactor from your local rental place. That'll run you somewhere around $50 to $75 a day, roughly speaking, and you go over that sand until it stops giving under your boot. That compacted, level pad is what your tank sits on, and it's the difference between a tank that lasts 25 years and one that cracks in 5. Now for the plumbing. And this is where most of your labor and a good chunk of your money is going to go, but it's also the part you can absolutely do yourself with basic tools. You're going to run pipe from your gutters down into the tank, and you've got a few ways to do that. The simplest is just sitting the tank right under a downspout, but that means your tank's stuck right against your house, which isn't always practical or good looking. The second way is building an above-ground ramp, sometimes called an aqueduct, that lets gravity carry the water to a tank set further away. Works fine, but it eats up yard space, and it's one more structure to maintain. The method I used, and the one most serious setups use, is a buried pipe running underground in a U-shape, working off the same principle as a drain trap under your sink. The water runs downhill, underground, out of sight, and pops back up into the tank. For that to work right, there's one rule you cannot skip. The pipe coming down from your gutter has to sit higher than the pipe going up into your tank, with at least 18 inches of difference between the two. That height difference is what pushes the water uphill into the tank without needing a pump. Skip that, and you'll get standing water in your gutters and pipes that never quite drains, which in the summer means mosquitoes, and in the winter means ice sitting right where you don't want it. On pipe size, don't cheap out on diameter to save a few bucks. 4-inch PVC drain pipe, sometimes labeled sewer pipe at the hardware store, Schedule 35, is the standard, and it's noticeably cheaper than 6-inch pipe. I'd estimate you're looking at somewhere around $2 to $3 a foot for 4-inch, versus closer to $6 or $7 a foot for 6-inch. But if you're running a long distance or you've got a lot of bends in your layout, that smaller pipe can bottleneck during a heavy storm and back up right out of your gutters. I learned this the hard way. My first layout had 5 bends in it, 2 45s and 3 90-degree turns. And the first big storm after I hooked it up, water came shooting back out the top of my downspouts instead of flowing into the tank. I ended up reworking the whole inlet with wider pipe and fewer turns, which meant custom welding a stainless steel fitting to marry a couple different pipe sizes together at an angle instead of a hard turn. That's a more advanced project, and honestly, most homeowners doing a smaller system won't need to go that far. Just keep your bends to a minimum and size your pipe generously, and you'll save yourself the headache I gave myself. I'll also tell you, because I promised I would, that I put together a free home repair guide with checklists and tool lists for projects just like this one, rainwater setups included, and it's sitting right there in the description below this video if you want something to print out and take with you to the hardware store. Once the water's in the tank, you need a way to pull clean water back out, because sediment settles to the bottom no matter how good your screens are up top. The cleanest water in any tank sits about 6 inches below the surface, so you want what's called a floating filter intake, which hangs suspended at that depth and moves up and down with the water level. You can buy those pre-made online for somewhere around $150 to $200, or if you're handy, you can rig your own out of a length of flexible tubing and a foam float, which is what my grandfather would have done, but I bought mine, because some days I'd rather spend the money than the afternoon. From there, water goes to a pump. I run a standard household pump paired with a small pressure tank, which keeps the pump from cycling on and off every time somebody turns on a faucet. That combination will run you somewhere in the neighborhood of $400 to $600, depending on the pump size. And it's a straightforward install if you're comfortable with basic plumbing and a little bit of electrical work. If you're not comfortable running the electrical side of a pump circuit yourself, that's a good time to call in a licensed electrician. A pump pulling water uphill under load is not the place to guess about wiring. Then comes filtration, and this is where the real safety of your water gets decided. First stage is what's called a spin-down filter, which uses centrifugal force to fling out the bigger particles, sand, grit, bug parts, whatever got past your screens. Runs about $30 to $50 and you just rinse it out every so often. After that, water passes through a 5-micron sediment filter, then a 5-micron carbon filter that pulls out any chemical taste or contaminants, and finally a fine filter down around 0.2 of a micron, which is small enough to catch the vast majority of bacteria and viruses. All told, a good multi-stage filter setup runs somewhere around $200 to $350, and you'll replace cartridges maybe once or twice a year depending on how much water you're moving through it. In my house, we take it one step further. Anything we actually drink or cook with comes out of a reverse osmosis filter under the kitchen sink, which filters down small enough to catch essentially everything, viruses included. If you don't want to add an RO unit, the safer alternative is an ultraviolet sterilization unit right before the water enters your house, which uses UV light to kill off anything that made it through the earlier filters. Either one works. What doesn't work is skipping this step entirely and assuming a tank and a screen is enough to make water safe to drink. It isn't, and I wouldn't want any of you getting sick over cutting a corner I told you not to cut. Last piece, and I want to be real clear about this one because it's a safety and code issue, not just a preference. You need a backflow preventer installed at the point where your rainwater system could ever connect to municipal water, if you're on both systems like I am as a backup. That little device makes it physically impossible for your rainwater to flow backward into the city supply. Most places require it by law, it typically needs an annual inspection, and it exists to protect everybody on your street, not just you. This is another spot where, if you're not confident doing it yourself, get a licensed plumber to set that fitting. It's cheap insurance against a genuinely serious problem. Now let's talk about why all this actually works, because I don't want you just taking my word for it. Water moving from a higher point to a lower point through a sealed pipe doesn't need a pump. That's just gravity and basic physics. The same principle as a drain trap or a siphon hose you'd use to empty a fish tank. As long as the outlet is lower than the inlet, water flows downhill through the pipe, even if the pipe itself dips underground along the way. That's not a trick. That's just how fluids behave under pressure from their own weight. The filtration side works because contaminants come in different sizes, and each filter stage is built to catch a narrower range than the one before it. Sediment and grit get caught by simple mechanical straining. Think of it like a sieve. Bacteria are small, but they're still large enough that a fine enough filter, in the range of a fraction of a micron, will physically block most of them. Viruses are smaller still, which is why the final stage of real drinking water protection, whether that's reverse osmosis or UV light, has to be capable of dealing with something that small. None of this is guesswork. It's the same layered filtration logic municipal water systems use, just scaled down to fit behind your house. And on the roof and gutter side, metal roofing is preferred for drinking water collection because it's chemically stable. It doesn't break down and shed compounds into water running across it the way asphalt shingles can, especially newer ones treated with certain coatings. That's not a knock on shingle roofs generally. They're fine for keeping rain off your head, just not ideal if that same rain is headed to your kitchen faucet. Let's talk money, because that's usually what gets people off the fence on a project like this. A basic setup, a modest tank in the 1 to 2,000 gallon range, gravity-fed piping, a pump, pressure tank, and a solid multi-stage filter. I'd estimate you're looking at somewhere between $2,000 and $4,000 in materials if you're doing the labor yourself. Hire a contractor to do the whole thing start to finish, and you could easily see that number triple, sometimes more, because a lot of contractors treat rainwater systems as a specialty project and price them like one. That's not them being crooked necessarily, it's a less common job for most crews, so they build in a bigger cushion. But it does mean a motivated homeowner willing to rent a compactor and run their own PVC can save real money. On the flip side, I'd steer you away from the all-in-one, pre-packaged rainwater kits you sometimes see advertised online for $800 or $900 that promise a complete house system in a box. Most of those undersize the filtration and skimp on pipe diameter to hit a lower price point, and you'll end up replacing parts of it within a year or two anyway. Spend your money on a properly sized tank and a real multi-stage filter, and skip the shiny, bundled kit. And here's the ongoing savings, since that's really the long game with a system like this. Once it's built, your only real running costs are filter cartridges, maybe $50 to $100 a year, and the electricity to run a small pump, which is genuinely minor. Compare that to a municipal water bill, or compare it to what it cost my family to sit through a week without water back during that ice storm. Bottled water at whatever price folks were willing to pay once the shelves went empty, plus the stress of not knowing when the tap would come back on. That's the kind of cost that doesn't show up on a spreadsheet. If you'd rather build something like this yourself than write a check to a contractor for triple the price, hit subscribe and give this video a thumbs up. It genuinely helps me keep making videos like this one instead of just fixing my neighbor's water heaters for free, which, believe it or not, is still most of my week. So here's what I'd like you to do this weekend. Walk your property and figure out where a tank could realistically sit. You want it reasonably close to a downspout, on ground you can level without moving a mountain. Measure your roof's square footage so you know roughly how much water you can expect to collect off it. Check your local rules because most states allow rainwater collection outright, and a lot of them actually protect your right to do it. But a few places have restrictions, so it's worth 10 minutes on your county website before you buy a single pipe fitting. And if you're serious about this, start pricing out a tank size that actually matches your roof and your household's water use, instead of guessing big or guessing small. That free guide I mentioned earlier has a simple checklist for exactly that calculation, so grab it out of the description if you want a head start. That water bill I showed you at the start of this video, the one that's about as close to zero as a water bill gets, that's not magic, and it's not some trick I'm keeping to myself. It's a roof, some pipe, a filter, and a weekend or two of honest work. Tell me in the comments, what's the worst repair or utility bill surprise you've ever gotten hit with? I want to hear it, and I bet some of you have stories that'll make my ice storm sound like a minor inconvenience. Next week, I'm going to show you what I did to keep my wood stove running efficient through a whole winter without burning through a full cord of wood by Christmas. So if that sounds useful, stick around for it. Fixing it right isn't about being fancy. It's about taking care of what you've got and the people who depend on you.